All right, welcome to the Explainer. Today we're going to pull back the curtain on a real powerhouse in the Java world, a tool that has seriously saved countless developers from some major headaches, Hibernate. But to really get why it's so useful, we first have to talk about the problem it was built to solve. So let's start with a really fundamental question. Picture this. Your application's code thinks like a sophisticated architect, right? It's all about complex, interconnected objects. But your database? It's more like a super meticulous librarian who only thinks in simple flat tables. So how in the world do you get those two to have a conversation without everything getting lost in translation? Well, this communication gap actually has a technical name. It's called the Object Relational Impedance Mismatch. And it's a mouthful, I know. But basically, on one side, you have your object world, with all its cool concepts like classes and inheritance and these complex relationships. And on the other side, you've got the database world of tables, foreign keys, and joins. They don't speak the same language. And that is exactly where the idea of object relational mapping, or ORM, comes into play. You should think of it as this brilliant multilingual translator. It's a programming technique that literally sits right in the middle and handles all the messy work of converting data between these two very different models. It's the bridge across that gap. And that right there brings us to the star of today's show, Hibernate. Hibernate is one of the most popular, most powerful implementations of this ORM idea. It's an open source tool that acts as that essential translator, specifically for Java applications, making it so much simpler for your code to talk to a database. Now, Hibernate is no rookie. This thing is battle-tested. It was first cooked up by Gavin King and his team way back in 2001, and it has been evolving and improving ever since. Today, it's a totally modern tool, using the latest industry standards like Jakarta persistence. That kind of longevity just proves how relevant and powerful it still is. So why do developers love this thing so much? Well, let's get into what I like to call Hibernate's programming superpowers. These are the key features that save developers a ton of time and can seriously boost an application's performance. Okay, so here's a quick look at the whole arsenal. It's lightweight, it's open source, and it's built for high performance. You've got its own query language, HQL, some really powerful caching, automatic table generation, scalability, and something called lazy loading. But a couple of these in particular are absolute game changers. So let's zoom in on those. First up, we have HQL, the Hibernate Query Language, and this is just brilliant. It looks a whole lot like the SQL that developers already know, but here's the twist. Instead of writing queries about tables and columns, you write queries about your Java objects and their properties. And the best part? It's completely database independent. You write one HQL query, and Hibernate automatically translates it into the perfect SQL for whatever database you're connected to, whether it's MySQL, PostgreSQL, you name it. Next, superpower number 2, speed. We all want faster apps, right? Hibernate comes with built-in caching, and the idea is simple, but its impact is huge. By storing data that you use all the time directly in memory, Hibernate avoids having to make those slow, repetitive trips to the database over and over again. And the result? Your application just feels way faster and more responsive. And this really leads us to its biggest superpower, its core value, true database independence. Look, every database, whether it's PostgreSQL, MySQL, or SQL Server, has its own little quirks, its own specific syntax. Hibernate handles all of that for you, automatically, using something called a dialect. You just tell Hibernate which database you're talking to, and it figures out the rest. It's a huge relief. No more writing custom, database-specific SQL. Okay, so how does all this magic actually happen? Let's pop the hood for a second and take a quick look inside the Hibernate engine. Now, it might sound intimidating, but I promise you'll see it's built on just a few core, really logical components. So anytime you do anything in Hibernate, it follows this basic life cycle. You start with a configuration, which then creates something called a session factory. That factory, in turn, gives you a session, and inside that session, you manage your work with a transaction.
Let's break that down piece by piece. So everything kicks off with the configuration object. This thing gets created once and only once, right when your application starts up. Its whole job is to read a special setup file, usually called hibernate.cfg.xml, to get all of its instructions. You know, how to connect to the database, what the password is, and which of your Java classes are supposed to map to which database tables.
So once that configuration is read, it's used to build the session factory. Now, this is a big, heavyweight, thread-safe object. Think of it as the main engine part. You only create one of these for your entire application. Its main job is to act like a factory, just handing out individual session objects whenever a piece of your code needs to talk to the database. Now, here's a key detail. When you ask that factory for a session, you've basically got two choices: open session or get current session. If you use open session, you always get a brand new session that you are responsible for. You have to manage it, you have to close it manually. But get current session, it's much smarter. It'll reuse an existing session if one's available, and it lets Hibernate handle all the cleanup automatically. Honestly, it's almost always the faster and definitely the safer choice.
And this brings us to the session object itself. Now, unlike the big factory, a session is super lightweight and short-lived. This is your workhorse. This is the main interface your code actually uses to save, update, delete, and fetch your data from the database. The pattern is simple. You create one, you use it for a quick task, and then you get rid of it.
And finally, wrapping it all up, we have the transaction. And this is your absolute safety net. Any work you do inside a session, let's say you're saving a new user, is wrapped in a transaction. This ensures that all the database operations for that task either succeed completely, that's a commit, or if anything goes wrong, they fail cleanly and leave the database totally untouched. That's a rollback. It's what guarantees your data stays consistent and safe. Okay, so let's see how all of this comes together in practice. Now that we understand the core components, let's look at the high-level blueprint for actually building your very first Hibernate application. It really just boils down to these 6 pretty straightforward steps. First, you set up your Java project and add the Hibernate libraries. Then you create your simple Java class, the Pojo, which is the object you want to save. Next, you create that all-important configuration file we talked about. After that, you write a class that uses the session and transaction to actually store or retrieve your data. And finally, you just run it. You know, when you really think about it, Hibernate is so much more than just another tool. It's a powerful abstraction. It solves a really fundamental problem by elegantly bridging that huge gap between the world of objects and the world of tables. And that leaves us with a final thought to chew on. If we can create a translator for 2 systems as different as these, what other impossible divides in technology are we going to conquer next? Thanks for watching.